Hey everybody, welcome to adding and subtracting rational expressions, the final video. This is where you're going to add or subtract, in this case both adding, rational expressions that have different denominators. Okay, so you should be familiar with the other videos on LCM. And so what we're going to do first here is, so here's our first example. We're going to take x minus 1 over x squared plus 3x plus 2 and add to that x over x plus 1. So off the bat we see two different denominators. So we have x minus 1 over x squared plus 3x plus 2, and to that we're going to add x over x plus 1. So the first thing you want to do is factor, because we need the LCM. Okay, so we're going to factor, I switch colors here, we're going to factor this denominator. Two numbers that multiply to be 2 and add to be 3 are x plus 1 and x plus 2. So the idea of the LCM is listing all the factors of both, and then if there's any repeats, just write it to the highest power. And so we see that x plus 1 repeats. So our new denominator is x plus 1 times x plus 2. And then we do not have to write this one because it's already part of that LCM. So notice how this first fraction has exactly what the denominator is. So x minus 1 just comes along for the ride. However, if we look at the second fraction, so here's our plus sign, we're going to do plus, we're going to put that x there. That x, this denominator doesn't have the x plus 2, so that's got to be, that x has to be multiplied by x plus 2. Okay? And so essentially what we've done is you take x plus 2, multiply it here, and x plus 2 multiply here. That's what we've done. Okay, so now we're not done. We just have to clean up the numerator. Okay, we don't have to do anything with the denominator, so we have x minus 1, and there's our plus sign. Okay, x times x is x squared. Okay, x times 2 is 2x. So there's our simplification, and then leave your denominator. I think I'm going to run out of space here. So what we're going to do now is combine like terms in the numerator. And if that can be done, which it can, look, we have 1x squared, so leave that. Okay, and we have x plus 2x, which is 3x's, so we have 3x's minus 1. Okay, let's see, we got that all over our denominator, and we should see if that can simplify down. Okay, two numbers that multiply to be negative 1 add to be 3 is not possible, so this is simplified. That's your simplified answer. Okay, and now let's look at our second example here. Again, we have two things that we're going to be adding together, and so I'm going to go ahead and rewrite the first one here, x over x plus 3, and I'm going to go ahead and factor the denominator of our second fraction. That's the only thing that can be factored here. So difference of two squares, two numbers that multiply to be negative 9 and add to be 0 are x plus 3 and x minus 3. And you can see now the denominators share a common term, x, or common factor, x plus 3. So what's going to happen here is we're going to list the factors, the LCM. We're going to list the factors. We're going to do x plus 3 and x minus 3. And we do not have to write x minus 3 twice. This one already has it. So you just do the first power. Now, x here, that fraction is missing something here. This x plus 3, it doesn't have the x minus 3. So this is going to get multiplied by x minus 3. And we're lucky here because we have a plus sign. And the negative 18, that denominator is the LCM, so we don't have to add or multiply it by anything. So it's just plus negative 18. So we simplify, we get x squared minus 3x minus 18 all over x plus 3 and x minus 3. Okay? Now we got to see if we can factor this one. Two numbers that multiply to be negative 18 and add to be negative 3. Okay? So our set of parentheses, x and x. Well, that would be minus 6 and plus 3. So we will be able to simplify something out of this. Okay, so we're going to go ahead and do that, and notice, okay, so the plus 3's are gone. Now in this example, it didn't ask us to list any of the restrictions, so I didn't here, but if I was going to list restrictions, okay, it's what my denominator can't be. And if I go back up here, okay, all back up even to the original, plus 3, they share a factor. X could not be 3, X can't be 3, and X can't be -3 here because it would make our denominator 0 and that would be undefined. It didn't ask for that, but if they do ask for that, you need to be able to list your restrictions, and we'll talk more about that in class. So that is how you add add rational expressions that have different denominators. Okay, so if you have any questions or comments, let me know, and we'll see you next time.